Okay, so the third objective in our lesson is to differentiate on one hand between speed and velocity, and on the other hand between average speed and instantaneous speed. Okay, according to what was explained in the previous videos, we said that we defined a position vector and how can we find its coordinates and calculate its magnitude. Even to make things simpler, we are not going to consider two axes, we are going to consider an object moving on a straight line along one axis, which is the x-axis. To be able to calculate its average speed, we can apply a simple formula, which is total distance over total time. And let me here differentiate between the speed and the velocity. The speed is the magnitude of the velocity. Magnitude, إمتى. However, when we talk about velocity, the velocity includes the speed and the direction. يعني here the object is moving مثلا to the right. So the velocity vector v vector, after calculating the magnitude, we are going to express it in terms of vector using I vector. First of all, let us talk about the speed as magnitude. Here they give you an example. If a car travels 150 kilometers in 2 hours, its average speed over the 2-hour period is 150 kilometers per 2 hours, يعني 75 kilometers per hour. So what did we apply here? We applied the formula V average equal total distance over total time. And here you have to show delta t when we talk about duration. Delta t, يعني هذه triangle which is delta, you have to write it in this way. Why? Because it shows the difference in time between two different instants. لحظات الفرق بالوقت بين لحظتين. Okay? So V average is D over delta T. هلا, the average speed of a moving particle between two instants is the quotient of the distance covered by the particle between these two instants by the time interval between them. What is the SI unit of distance? It is meter. The SI unit of duration is seconds, and the SI unit of the average speed, V average, as you can see with an index A, is in meters per second. Okay, so in this book we are going to study only rectilinear motion, as I mentioned before. Hello, what is instantaneous speed? Instantaneous speed is the speed at a certain instant. How can we calculate the instantaneous speed? Let's read the example given here. A passenger sitting in a car and watching the speedometer does not necessarily read 75 km per hour at an instant during the motion. He finds that the reading varies from time to time depending on the state of the traffic. The same example here above. We said that during the whole 2 hours the car traveled a total distance of 150 kilometers. So the average speed, the car was moving at an average speed equal 75 km per hour. But this doesn't mean that the car was moving at every instant at this speed. Sometimes maybe the car have accelerated or decelerated or stopped because of the traffic jam. So the instantaneous speeds at different instants change. However, the average speed is calculated to be 75 km per hour. So the instantaneous speed V at an instant t is approximately equal to the average speed between two instants t1, t2, such that t1 and t2 are very close to each other. يعني, instead of taking the duration within 2 hours between two consecutive instants, يعني if it is مثلا I want to calculate the instantaneous speed at 8 and 30 and 5 seconds, I can take the distance covered between 8:30 and 4 and 8:30 and 6 seconds. So here the time interval is only 2 seconds. That's why I can consider myself يعني in this case calculating the instantaneous speed. So the instantaneous speed V at an instant t is approximately equal to the average speed between the two instants T1 and T2 such that T1 and T2 are very close to T اللي أنا بدي هيدي T اللي أنا بدي أعمل calculation the speed لإلها instantaneous speed لإلها such that is T between T1 and T2. The smaller the time interval delta T, the closer the average speed is to the instantaneous speed at this time T. Again, the instantaneous speed is calculated in SI units, which is meter per second. Direct application of what we have discussed. Figure 14.9 shows the motion of a puck left without initial speed on an inclined air table. The puck is an object that moves. We should have shown it to you experimentally in the lab. You can look it up on the YouTube. Anyway, it's an object that moves and leaving dots behind it showing successive positions. يعني first it started here بتعمل dot. After مثلا after 60 milliseconds بتكون معيرة. It's adjusted such that it leaves a dot every 60 milliseconds. Okay, so after 60 milliseconds the puck left reached this position. Then after another 60 milliseconds it reached a third position, and so on, leaving these dots behind it that represent successive positions of this moving puck. Type. What is this question here? So we are given that it started without an initial speed. يعني sorry, I was explaining it from 6 to 0. Actually we start from 0 and we go on to 6. يعني again it started from the origin here without initial speed. يعني its speed at T0 was 0. After 60 milliseconds it reached position 1. After another 60 milliseconds M2, 60 milliseconds M3, and so on. So it's moving along this straight line. And M0 till M6 are the successive positions of this moving puck. Now part A, determine the average speed of the puck between T0 and T3, T1 and T4, and T2 and T6. If you want to apply the formula which says that the average is equal to the total distance over the total time, we're given the time, but what is still missing? The distance. So using your rulers now, you have to to measure the distance between, as long as they said between T0 and T3, يعني using your ruler, you have to measure the distance between M0 and M3. يعني in other words, you have to measure the length of the segment M0, M3. Okay, then divide it by the total time. What is the total time between these two instants? How many intervals? How many taus? 60 milliseconds, 60 and 60, يعني 3 times 60 milliseconds, which is 180 milliseconds. Same procedure in order to measure the average speed between T1 and T4. T1 and T4, using your ruler, you measure the distance M1, M4 in centimeters, of course you are measuring. And concerning the time interval, 60, 60, 60, so this is 60 times 3, so it is 180 milliseconds, and you divide the distance by the time. You convert from centimeter to meter and from millisecond to second. From centimeter to meter you divide by 100, from millisecond to second you divide by thousands, and you get the average speed between the given instants in meter per second. Now what about determining part B, determining the instantaneous speeds of the puck at instants T1, T2 and T3, and what can you deduce? T1, how can I measure the instantaneous speed at T1? I have to choose a time interval. So بالنسبة لإلي now, T1 is the T that we discussed here. The T1 here is between which two instants? What are the closest instants before and after to T1? They are T0 and T2. So the instantaneous speed of T1 at T1 is the distance M0, M2 divided by 2 times 60 milliseconds, which is 120 milliseconds. Similarly for T2. T2, what are the closest successive instants with respect to T2, they are T1 and T3. So the instantaneous speed T2 is equal to the distance m1, m3 divided by 2 times 60 milliseconds, which is 120 milliseconds. Similarly for T3, the successive or the closest ones are T2 and T4. So the instantaneous speed T3 is equal to the distance m2, m4 divided by 60 and 60 and 120 milliseconds, and don't forget to do the unit conversions. You can find the solution here. You can verify your answers. And what can we deduce then? The average speed, as you can see, increased 0.128, 0.183, 0.229, and the instantaneous speed is increasing 0.108, 0.15, 0.183. So we deduce that the speed is increasing, and thus this motion is accelerated motion. However, as I mentioned at the beginning of this video, that the velocity is what? That the velocity is the magnitude plus the direction. Yani in the above, or in the previous example, we calculated the speed, which is the magnitude of the velocity. Now, how can we represent the velocity of a moving object? Suppose that, given an example 14.4, a train moves on a rectilinear rail. At an instant t, it passes by the midpoint m of its path, and its velocity can be represented by the vector mn of length 2 cm drawn to the scale 1 cm to 10 milliseconds. Determine at an instant t the direction of motion and the magnitude of the velocity in kilometers per hour. See, the velocity, not the speed, the velocity is represented by a vector v at this position. In what direction? In the direction of motion. Type. Given a scale 1 cm to 10 millisecond, v 2 cm, this means that the speed, the magnitude is 2 cm times 10, which is 20 meter per second. Then we convert it from meter per second to kilometer per hour by doing the necessary conversion, which is multiplying by 3.6. From meter per second to kilometer per hour, we have to multiply by 3.6.